You haven't got a napkin, have you? Tissue?
Tissue.
Yeah, napkin, something. Even a piece of old paper, anything. I'm making a mess. Old paper? Here, it's okay, no, it's okay. No, it's okay. I'll take a page from this book. Don't tell me.
He won't know.
He
Yeah, the bin not.
He won't notice. Oh wait, the video's recorded. Oh no!
This is much flavor.
yeah. Oh, Mir, you're back. Right, let's have a look now. Practical problems. The last part of the vectors. Okay, so again, there's not one way to do this because they're practical problems that can always be different, but I'll do one as an example. Yeah? Okay. So, let's have a look. Right, two cars are 100 meters from a crossroads. So you have a crossroads, and there's two cars and they're both 100 meters from the crossroad. One car's moving at 10 while the other car's moving at 30. You can't for this type actually. So this car is moving here at 30 meters per second, and this one is moving down here at 40 meters per second, and this distance here is 100 meters, and this distance here is 100 meters.
What is the distance from each other?
Don't know, we have to work it out. It'd be square root.
Oh, distance from the car to the origin.
Oh yeah, this is the car to here is 100, and here to here is 100. Who will get to the crossroads first, car A or car B?
Okay.
Car A. Will these cars crash? No. But at some point in their journey, like maybe when A is here and B is here, for example, they'll be nearest to each other. Yeah. At the beginning they're far apart. Later they'll be near each other, and then much later, when B is over here and A is down here, they'll be far apart again. We want to know what is the shortest they'll be.
When the A is in origin.
No.
Why?
No, not necessarily. Let's have a look. In fact, I don't think it will be. Right. So, what I'll do first is, I'll write down a vector for A. The A has no J part, so the J is 0. It only has an I part. When the time is 0, what's the I part? I'm sorry, I'm stupid, sorry, 0. I want to know where the A is at the beginning. I is 0 and J is 100. Yeah. This is where it is at the beginning, yeah? 1 second later, where is it? 0 and 60. Because it travelled 40 meters. 2 seconds later, where is it?
20.
At 20. So, A is at 100 minus 40t. Each second it loses 40, yeah? So that's equal to 0, 100, plus t times 0 minus 40, yeah. Likewise for the B, the J part is 0, and what will be the I part? Yeah. That is 100, 0, plus t times minus 30 and 0 here. Yeah? Okay, so that's the A, that's the B. We don't care about A and B. What we care about is the distance between them. Yeah? Which is AB, which is equal to B minus A. Yeah? Now, what is B minus A here? So that would be this one minus this one. So that would be 100 minus 0? 100. 0 minus 100? Minus 30 minus 0? And 0 minus 40? 40. Yeah, 40. Yeah. So this is AB. Okay? But I don't care about the vector AB. What do I really want to know? It's the length of AB. I want the length of AB. So I need to calculate the magnitude of AB. Yeah? Now, just to make the thing a little bit easier, I'll calculate the magnitude squared, and then later I'll square root it. It's a little easier because I don't want a big square root at the moment. So the magnitude squared is equal to AB dot AB, which is equal to this dot itself. Yeah. So I'll just write two big brackets here. Dot this one here. So that would be 100. You know what? To make this a little bit easier, I think I will write this back as one vector. 100 minus 30t minus 100 plus 40t. Yeah, so the
100 minus 30t squared.
Yeah. I think it's a little easier, yeah. Okay, so this would be 100 minus 30t squared plus minus 100 plus 40t squared. So that's equal to, I have to expand this, 10000 minus 6000 plus 900 t squared plus 10000 minus 8000 t plus 1600 t squared, which equals 20,000. Well, let's do the t squareds first. 2500 t squared minus 13000. Yeah? 14,000, thank you. 14,000. Yeah, t plus 20,000. Now I'll put in the square root. So the magnitude of AB, which is the distance between them, is equal to the square root of this big number. Musharif, you were asking me what is the distance between the cars at the beginning, weren't you? Yeah. So you could use this formula, and what would you make t equal to? 0, and you would get the distance. So that would be square root 20,000. What's that, please? So it should be about 140, I think. Square root 20,000.
Which is the Pythagoras.
Yes, which is the Pythagoras, yeah. 140?
Square root of 20,000.
Yes.
It's 4, 3, 0, 3, 0, and 00.
Let's see.
How can it be more than?
Come on, give me.
It's square root. Sorry. 141.40.
Yeah. Okay, but we don't want this, we want the shortest distance. Now, what I'm going to do, complete the square. I know. I take the 2500 out. So this is t squared minus 1400 over 2500 t plus 20,000 over 2500.
14 over 25.
14 over 25. And this one is, what's this one? 20,000 over 2,500. 8. That's nice. Do you remember how to complete the square? Square root 25, that would be 50. And then this is square root something squared plus something. So this is t minus a half of this, which is 7 over 25. And then type in on your calculator this, 8 minus 49 over 25. No, 49 over 625. It's this minus this squared. What do you get?
4951 over 65.
Are you sure? 4951 over 625. Okay. So that's kind of it finished. If you look at this formula, what is the time that will make this a minimum? At what time? Do you, no? Do you remember this from completing the square?
Yeah.
7 over.
You remember this, good. So when t equals 7 over 25, d will equal its minimum value, which will be square root of this number times 50, please. So if you can type in 50 root 4951 over 625.
140.70.
140? It's not that much smaller than the distance at the start. 140.70. Right, let me just check the answer for that. 4 seconds and, no, 4 seconds. Something must have gone wrong.
I think the half we took of 7 over 25 is
Yeah, that's a half, isn't it?
14 over 25.
Yeah, 14 divided by 25 divided by 2. Yeah.
Why didn't we take the quadratic? Why didn't we use the quadratic formula? In this
No, not for completing the square.
Yeah, but before that.
This is not solvable.
No, it is. It is. This is an exam question.
Then why you didn't solve it?
No, because this quadratic has no solution.
Yeah, it's
That's what I'm saying.
Oh, okay. Oh, sorry. Yeah. Yeah. This quadratic looks like this. This is the time and this is the d. And at the beginning the distance is 141 and then it decreases to a minimum and then it increases again. Yeah, thank you. So there's some number mistake here. Let's see if we can find it. This is right. This is right. This is right. Okay. Yep. 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 No, Mr. Reeve, please, I need your help. Look at it and try and find the mistake with me.
I don't know.
I think
No, but even if you just look.
with that minus 100 plus 40 t square.
No, this is right. This is right. This is right. 1600 plus 900, 2500.
Yeah, but it shouldn't be a minus.
Which shouldn't be?
The t.
This one? Is that the problem?
Oh, no.
It's okay? Minus 6,000 minus 8,000.
Yeah, it's 14.
That's 3 zeros. And here I wrote 2 zeros. I lost a 0. So that's a 0. So that's a 0.
It's 1 over 40 over 25 then.
So that should have been 14. You see, it was going to be 28 over 5. So now it's going to be 14 over 5. And then this one's going to change as well. So maybe there's another 0 I lost. Is this 2500? Yeah. Outrageous.
How can it
25? Done again. 1600
Yeah,
plus.
16 plus 9 is 25.
Yeah, okay. Yeah. So I made a mistake here, which then changes this one here. I think maybe next time I'll change them to 4 meters, 3 meters, and 10 meters.
Yeah.
Might make it a bit easier then. Okay, well this is how you do it anyways.
Let's do the coursework.
Oh yeah, sorry, you wanted to have the question then, so let me have a look at that then.
These type of questions come in the exam, like practical problems. I think for the probability they might ask.
Practical problems?
For probability.
Once.
In B.
No, only came up once.
This kind. But I mean on the general practical problems they are in B.
Yeah, but usually in the trigonometry, the sequence and series, or the calculus.
The log one.
And the log one. Yeah. Oh, and remember recently we did the ODE?
Yeah.
Remember those practical problems?
The same log. You just integrate it before.
Yeah, it is, yeah. It usually just has an E in it. Okay, so.
This is a quadratic structure.
Yes?
My window is corrupt. What should I do now?
I have to take it to his shop. What I'm going to do, I don't want to be exactly the same because no, because this is your coursework.
Yeah.
What? I'll give something
It's
similar.
not coursework, not a computer programming coursework.
I'll do this function. 1 over square root pi
I have problem even in the
minus a half x minus 1 squared. I'll type this in.
Why?
Because if I do your one, that is unfair to the other 3 students.
Okay, do it for the sigma and x.
Okay.
Are the difference from each of us. Okay. Change
No,
this number.
Mr. Steven, do it for him. He will do it for us.
Okay, hang on. What is the formula? 1 over sigma
square root
2 pi e minus a half x minus mu over sigma squared.
Choose whatever sigma and
Give me a number 1, 2, or 3. 8, 4 it is. So sigma's 4. Give me a number 1, 2, or 3. Now your turn.
No, it's 16.
No, it's not. Give me a number 1, 2, or 3. 10? Okay, I'll use 11. Mu equals 11. Right. So, I want now this formula. Fx equals 1 over 4 root 2 pi e minus a half x minus 11 over 4 squared. Yeah? Fair enough. Okay. So, let's start by typing in this part first. 1 over 4 root 2 pi. Okay. So that's equal to brackets 1 over bracket, bracket, bracket. And then in these brackets here, I'll put in the what was it? 4 times square root 2 times pi. So that's...
How many you close brackets put?
Yeah, you have to be careful here. Now watch. I'll write it here. First, I need a bracket to put this in.
Yeah.
Then it's going to be 1 over, and I need another bracket for this part. So here, I need a 4 times, and now I need this one,
Yeah.
which is square root,
Yeah.
and then I need brackets for the square root. And inside the square root is what?
2 pi.
2, and in Excel the way to type pi is like this: pi, Mishari, watch, pi bracket.
Both brackets.
Yeah, so you have 1, 2, 3, 4 closed brackets at the end here. No, it's recording, don't take pictures, it's recording. Okay, now let's look at the next part, this one here. So firstly it needs brackets. So, brackets. And then let's type it. So this would need brackets. Oh, sorry, star brackets. So I forgot my star. Okay. E, you type it like this. EXP, exponential, and then the power. So this is EXP brackets. Okay. Then you need -1/2 times brackets power 2 for this part. So -1/2 times brackets power 2. Now the inside part, I have x minus 11 over 4. So I need 2 brackets, the top and the bottom. X minus 11 and 4 go here. So now I have bracket slash bracket. 4 on the bottom one, x minus 11 on the top one.
X is 2.
Oh yeah, I'll just write x for the moment. So here, instead of x, we need to put in a cell. So if I put the x values in E, we'll say, I'll just write in here instead of that E1.
No, we have ordered before for the mu, like E1 for the x.
Yeah, I'm writing E1 for the x.
No, we didn't.
I did, I just typed it there. Oh, sorry. Now I know what you mean. I replaced the wrong one.
Wow.
This is 11, and this one is E1.
And you didn't give any.
No, and I put a value in here. So, 2. But if I copy this down, I can make 10 values. Like for example, x is -5, -5, and then we'll do -4. Now, wait. Let me draw this. Actually, let's go for more than that. Let's start at -10, and we'll go up in 1/2. And let me just copy this down. Up until 10. Too far. Huh? Not far enough. I need to go up to 10, I want to. Nearly. In the x, I want to go from -10 to 10, because I want to make a graph for you. A hill. Yeah. So let's make the graph. Insert chart. What type of graph do we want here? Scatter, good, yeah. So scatter with the lines. like this. You can kind of see it there. I only have half of the graph, I didn't go far enough, I guess. Next. Can I pick smooth lines? Lines, points. Next. X values are, oh no, my graph's too big. The X values are here. And then the next, we'll just say XY graph.
Why is it so dirty?
Minus 10 to 10. I didn't go far enough. I should have gone to 20. I only have half a hill. This is what you needed? So now you can finish it? Okay, we'll finish then. Well, we'll finish.